What is the first proof of irrational numbers in algebra? Have you ever wondered how we discovered that not all numbers can be expressed as simple fractions? The answer lies in the fascinating world of irrational numbers. Let's take a closer look at the first proof of irrational numbers in algebra. This proof is credited to Hippasus, a philosopher from ancient Greece who was part of the Pythagorean school. Hippasus made a significant discovery about the square root of 2. He showed that this number cannot be written as a ratio of two integers. This means that it is not a rational number, but rather an irrational one. To understand Hippasus's proof, we need to look at his method called proof by contradiction. He started by assuming that the square root of 2 could be expressed as a fraction, which we can denote as p divided by q here. P and q are integers that have no common factors, meaning the fraction is in its simplest form. From this assumption, Hippasus logically analyzed the situation. He concluded that if the square root of 2 could be expressed as p divided by q, then both p and q would have to be even numbers. This is because squaring both sides of the equation leads to the conclusion that p squared equals 2 times q squared. However, if both p and q are even, they share a common factor of 2. This contradicts the initial assumption that p divided by q is in simplest form. Since this contradiction arises, it means that the original assumption must be false. Therefore, the square root of 2 cannot be expressed as a ratio of integers, confirming that it is indeed an irrational number. This proof was groundbreaking because it expanded our understanding of numbers beyond just rational ones. It showed that there are numbers that cannot be neatly categorized as fractions. This discovery is not just a historical fact, it has real implications in algebra and geometry. For instance, the length of the diagonal of a square with sides of 1 unit is the square root of 2. This connection between number theory and spatial concepts is vital in many areas of mathematics. In algebra, irrational numbers play an important role. They help complete the number system, allowing us to find solutions to equations that rational numbers alone cannot solve. Understanding irrational numbers like the square root of 2 is essential for grasping the broader concepts of numbers and their properties. Hippasus's proof is often regarded as the first clear demonstration of irrationality. It laid the groundwork for future developments in algebra and number theory, helping learners appreciate the richness of mathematics. So, the next time you encounter the square root of 2, remember the journey it took to be recognized as an irrational number.